Hey everyone, I'm Gwen Shapira, and this is kind of an experimental talk. So it's going to be about Kafka and the service mesh, which may sound as coherent as a talk about apples and mastodons. So it's not 100% crazy. When I started to learn about the service mesh, which is kind of a popular thing to learn about these days, it almost looked like Kafka, which I'm well familiar with, and the service mesh are trying to solve the exact same problem from totally different directions. So this talk is basically about what the problem space, exploring the kind of problems that Kafka and the service mesh are both trying to solve, how they're solving it in each in its own unique way. I am kind of slightly going to assume that you know Kafka more than you know about service mesh. So this can be a good introduction to service mesh. And then I'm also going to talk about how they work together. So let's get started. The problem is that you have microservices. Well, then microservices are a good thing. They're not a problem in and of itself, but then they also have to communicate to each other. Like microservices are those small units of work that together make up an entire application, hopefully one that is valuable to your business. And in order to be a coherent application together, they have to communicate. They have to send messages to each other. They have to send information to each other. So most of us, when we're presented with microservices as a reality in our life, we say, oh, I know, they'll communicate to each other via REST API. So basically, if I need my service, if my service needs to get some piece of information or it needs another service to do something, you basically call an API that the other service provides and say, hey, do this thing, or hey, do you know about that thing? And this is all well and good, and I think we like doing it because it means it's very light on infrastructure and very easy to just get started with. So, you know, every language has its own HTTP server, it may have some REST libraries, and you can just get started. You don't have to install anything. You don't have to ask another team to install something. Super, super straightforward, no problem at all. The problems show up when you try to change the system, because this kind of pattern where you have a synchronous request response, right? One service makes a request, another service responds. This type of system leads to a point where the two services are very tightly coupled.
Sorry, can you go back to that?
This kind of system where you have one service calling an API in another service can lead to a place where the two services are very tightly coupled. So you have these APIs, and a lot of times they're written for a specific pair of services. So the API itself embeds some of the coupling, and every time you need to change the system, you have to think about how do you fit new things into those two services that are basically kind of tied together at the hip, and with the new REST API being the hip. And the other problem is that it also changes the way that responsibilities work. So, for example, you have this kind of scenario where if a person changes their address and you're an insurance company, you want to maybe give them a new quote because the new address maybe is a bit more risky, and now the car can get stolen, you know, fraction of % more, so they need to pay a few cents more for their insurance. Is it really the responsibility of the profile database where the address changes go through to know about the logic of the insurance quotes and know that they have to call new insurance quote when someone changes the address? It's kind of, you have your business logic now all over the place as a result. So this leads to two very big problems. First of all, making changes is risky. You have all those different dependencies that may or may not be documented. And if someone makes any change, then you kind of have a large blast radius. I want to change an API, and I have all those different components that are kind of like, oh no, you're changing this API. You have to have a big meeting. Does the new API fit in everyone? What the data I'm going to do the API change? Managing all those revisions is very, very difficult. The other problem is that when you want to add something new, it's going to need to talk to other services, which means that you're going to add new APIs. So you can't really add new functionality without talking to all those different teams and trying to align their priority and try to figure out how they will do work that will actually make your life easier, and whether you have to kind of recruit them to do it. It becomes a very intensive thing to add even the smallest bit of functionality, which is 100% against everything we wanted from microservices, which should have been those small, independent, agile team controlling their own destiny, doing their own thing. And in addition, you have all those lines of communication, and they share something between them. All those lines of communication, you need to do logging, you need to do monitoring, you need to handle errors. There's all those things that you need to do no matter what. But because you have all those different services, you have to solve the same problem in every single service, or maybe every single pair of services, making it an even bigger problem. So you kind of have this kind of operational complexity that is attached to it. And the really most difficult thing about microservices is data, especially when you have to join different data sets. So you have a lot of different services, and you're like, hey, you tell me the address, and you tell me the phone number, and you tell me the order status, and you tell me about the line items. And you know, if you have like 20 of them, one of them fails, now what do? If you try to ask them again, maybe the answer changed. How do I expose data for other people? What is a good way to expose it? How do I make changes to the data? A lot of the design of REST APIs and a lot of the thought about microservices didn't really take data into account. Like, they kind of assumed, oh, there's going to be a database, but is it going to be one monolithic database, a lot of small databases? How do we make sure that they're all remain in sync and don't go off into La La Land? It's a big problem. So when we look at the problem as a whole, we're looking at the problem of communication between microservices, and it's normally solved with REST API, but it doesn't give us everything we need. We need something that is more decoupled, something that is more flexible, that allows us to make changes in an easier way. We need more operational transparency built right into the system, not as an afterthought and not something that you have to ask services to do. And you need to make the system data aware. Data has to be a first-class citizen in the entire system. It can't be something that people just assume it's going to be okay somehow, YOLO. So this is basically the problem definition. And one way that we've seen people approach it is using Apache Kafka. So just in very short, what is Apache Kafka? It is a log. So you have events, it's an event log, and one event after another. Events are immutable. Kafka keeps them in a stream that is very well ordered. And basically, as events happen, you keep writing, we have a new order, we have a new insurance quote, you have a new address, you can just keep adding them to the list of things that happened. And then when you read it, you basically start at some point in time, and you keep reading on. What was the next thing that happened? Oh, and what happened next? And then what happened? So this is kind of the big idea, but it's really a distributed and partitioned stream of events. So you have a bunch of stream of events, they're organized into topics, and they're spread across a bunch of machines, and they're replicated. So this scales really, really well because of the way it is distributed and optimized. And it's not just that you can scale to a lot of stream of events and a lot of data, we also scale really well to a lot of consumers. And this is really key, because you have all those microservices and you want to have a lot of microservices. You want to enable communications through a lot of them. Like, big organizations will have maybe 30,000 microservices. You want to make sure that your message bus supports all of them.
The message bus supports all of them. Say that one more time.
You have to make sure that your message bus supports all of them. So the way it works for Kafka is that, first of all, your microservice subscribes to a topic and it starts getting events from all the partitions in the topic. If it's too much for one instance of your service, you keep adding few more of them, and they kind of load balance the partitions between them. They handle failover. This is all automatic and built into the system. If you need more microservices, you just add more and more of those consumer groups. And the key is that Kafka doesn't really keep all that much track. Kafka just stores data for a week or a month or 3 years. And it's up to the consumer groups to know, oh, we got all the events until event number 15. And when we say what happened next, it will be after 15. So it's very light in terms of overhead per consumer group, which makes it scale really well. And having this very nicely scalable message bus lets us basically go from this direct line of communications, which is very inflexible and tightly coupled, to something like this, where all communication happens via Kafka topics. So you can see that you have the blue service, and it's writing events to the blue topic, and everyone who needs blue events subscribes to the blue topics. The blue service writing the events doesn't need to know about everything else. Now, I agree that this doesn't look 100% simpler and clearer, but you can see that the lines of communication only go in one of two directions, which means that you do have something that is more organized. And it means that it's easier to track, and it's much more decoupled because the blue service and the green service don't really need to know about each other's existence. But the best thing is that now adding new services means that, oh, I need these pieces of information in order to do something cool. No problem, I'll just subscribe to the topic. I don't need meetings, I don't need to talk to anyone. This is like utopia. I can get stuff done without having meetings. What can possibly be better? And when we have like our big vision, we're thinking about everyone publishing their activity as a stream of events. All the applications, all the mobile apps, all the websites, all the clicks, and also all the databases, every insert, update, and delete, all those things go into this one big store of event streams. And then everyone can just use them without having all those big dependencies and just go and say, I want those events, and I can get shit done. So really, really nice. You have this immutable ordered stream of events that we also like calling logs. You have high availability built in, it's very scalable, and you have all those cool things that it gives to your microservices out of the box, like load balancing and high availability. But there is one more piece that you really need in order to have good coupling between services. So let me start by walking you through a scenario that has happened before. Imagine that you have a booking service because you're a big hotel chain and you have a booking service, and it has user ID because you want to know who did the booking, and you have a timestamp because you want to know when he booked something. And because you have all those independent microservices, then you have multiple microservices reading this topic. So you have someone writing the events to a database table, so that it will say, oh, the timestamp is a number, let me store it in database as a log. I have an attribution service. Check if someone reserved the hotel via a blog, and if so, send a bit of money to the blogger who made the referral. This is all nice. This means I need to know the dates because the whole deal depends on if it's close enough to the day of the blogging. And this means that I have to have an object, new date from this timestamp. I have a bunch more of those. And obviously me as a booking service, maybe I know that the booking database exists. I definitely don't know anything about the attribution service. It was added by someone else, somewhere in marketing. Nobody ever told me. And one day I decided that storing timestamp as a number is super boring and also hard to debug. And like there is a standard, something POSIX or ISO or something that tells me how to store the date as a string. So let's switch to a string. What's the worst thing that can happen? Well, obviously, the worst thing that can happen is that every single consumer that assumes that it's a number is going to fail. That's pretty bad. It's pretty bad because I'm going to be blamed for other people not sleeping at night and customers not getting their data and bloggers not getting the revenue and us getting sued and the company going out. It's going to be obviously quite terrible. But even worse, next time I want to make a change, nobody is going to trust me, right? So I have to find out who are all the people who depend on my service and sit them down in a meeting and say, I want to make a change to my timestamp, and what do we do now? And it's going to be a lot of negotiation. And this is the thing we try to avoid, right? I don't want to know who's using my data, and I definitely don't want to sit in a 4-hour meeting with them. So how do we get out of this? The thing to realize is that when you have those APIs, the APIs between the services are a contract. And what you normally do is in order to enforce the contract, you run a lot of tests and you treat those changes to APIs very, very carefully. You have rules on how to make compatible changes, a lot of rules for evolution, and you have a lot of tests to enforce those contracts. When you do this kind of event streaming, when you use Kafka for communication, you have the same thing. This is the schema of the event. all those fields and their types, this is your API. It's a bit more critical because the data is stored for a very long time. So you need to be very careful and make sure that you really test and treat them with respect and make sure that everything is compatible. And this is something that until not that long ago, we kind of lacked the tools to do, but we have them now. So this is where schema registry comes in. And schema registry has two parts to it. One is what we call last line of defense. The serializers in which you use to write Java objects to a network, they are aware of the schema registry. They know you're trying to write to topic A, and we only accept specific events with this specific schema on topic A. And if you try to serialize an object that does not match the schema on topic that is registered for topic A, we'll just get incompatible data error, and the bad event will never make it into the stream. None of the consumers will break, and you'll basically have to go and debug an exception. We put the pain where it belongs, which is with the person who made a change, who is also best positioned to address it. Notice that debugging an exception is kind of meh, especially in production, but it's gazillion times better than being blamed for a lawsuit and having 5 hours beating every week. So this is really good, having this last line of defense for mistakes, but we don't want to only catch mistakes when they go to production. So the schema registry is actually nicely integrated with your development workflow. So we have this Maven plugin, and you can basically, while you're developing, you made a change to a schema, you try Maven validate schema and the schema name, and you just get either pass fail, and you can build it into your unit test, you can build it to your commit hooks, your nightly build. Everywhere you like validating that your APIs didn't break, just build this Maven integration, and you're pretty much guaranteed to catch very early in your development process whether or not your schemas are compatible and whether or not you're allowed to make the changes you're trying to make. So this is super valuable. And using this combination of Kafka and the schema registry, we fixed quite a bit of things that broke in the way we communicate between microservices. We added a lot of decoupling. We made the system more flexible, not infinitely flexible, because some changes are allowed, some changes are not allowed. You cannot just go and move microservices, for example. You definitely need to know where Kafka sits physically, some IPs. We didn't solve anything about operational transparency. If anything, we may have made it slightly worse because now there's just more things to keep an eye on. But we solved a lot of the data problems of communication. So we made some headway, but only that much. And then when I looked at the service mesh, this is kind of funny because it's one of those very popular buzzwords, right? So I was reading about it and I was seeing blog posts and people were talking about it. And you know, one day it's like, enough is enough. I'm going to clear my entire weekend and learn what is service mesh. And I cleared my entire weekend, and about 5 minutes later, I found out that the service mesh is a proxy. Basically, it sits on the network and it takes messages and forwards them along. And this is not a big deal, and it's definitely not a new concept. I think I've been using proxies since maybe 99, year 2000, something around that. I mean, back in the old days, every company had their company proxies that did a bunch of like filter out bad websites and all kinds of stuff. So this is a proxy. It just sits on the network and moves things around, but it's a special kind of proxy, and it's special in two ways. And the one of them is that it is a proxy that sits on the server or on the node, on the container that has the microservice in it. So it is a proxy as a sidecar. And the point with a sidecar is that you take a component of an application, in this case, part of the network stack really, and you deploy it in a separate container to give it isolation and encapsulation. But the real cool thing is that once you encapsulated this part of logic, you can now reuse it everywhere. So you take a proxy and you basically deploy it with every single microservice that you have. What does it give you? It means that you're talking directly to the proxy. Remember that it used to be that you had to talk to microservices that were somewhere and you had to know who they are, they had to know about their version, you had to know so many things. Now you're pretending that the other microservice is on your machine. You're basically talking to localhost, and the proxy says, oh, it's actually a different microservice, let me forward the message along. So this is kind of interesting. This is the things that you're supposed to imagine. Your application is the big bike and you have a sidecar, and this is kind of custom, well integrated, but imagine that you can move the sidecar and attach it to other bikes as well. That's the idea. And when you have proxy as a sidecar, you can see that every one of your microservices, when they talk to each other, they basically talk to the local proxy, and the proxy forwards the messages along. And what does it give you? It gives us a lot. But let me walk through two really, really cool examples. Let's say that one of the microservices was redeployed because something happened and it now has a new IP. How do the other microservices know where to talk to? Well, they don't have to. Proxies, especially service mesh with a proxy, and I'll talk a bit more about it later, they basically do service discovery. So I keep talking to a port on my own local host, and magically my messages show up at the correct microservice, at the correct new location, and it just works, which is really, really cool. It decouples things and gives you flexibility in a very real way. You don't have to know how to find the other service. You keep talking locally. And you can do even cooler things. Imagine that someone really, really stupid wrote a server. You know the PHP developer in your company. You know who I'm talking about. And let's say that he, by mistake, has the following logic. If there's any error, especially like a timeout that he gets from a database or from a service, he'll basically just retry every millisecond until it succeeds. So like retry. Very often, and happened to me in my career more than once, this thing will absolutely crash a database. So an error that could have been easy to recover from is now becoming 6-hour downtime for the entire company because you just crashed the database. This is terrible. But suppose that there was a smart proxy in the middle and it can say, oh, it's trying every millisecond. What the fuck? Let's just pass along one of the retries maybe every second. So you're just dropping all those retries and not passing them along, and you only pass along the correct ones. This is fantastic. Now the database can recover, and the database doesn't even need to know about the stupid microservice that is everywhere. The microservice is stupid. The proxy is really, really smart. And the list of things that you can do there is actually kind of mind-boggling. So you have this one stable URI that happen to be on localhost for every service. You can build in service discovery. So those, you basically say, I'm talking to my order verification service, and the proxy will know exactly where to send it off. It's kind of like a DNS, but imagine a very easy to control, very programmable DNS that is instantaneously updated on all the machines you're using, that is very aware of your services and application logic. That's the kind of thing. You can add logging. Like a lot of applications have insufficient logging, and how do you debug stuff? You can make sure the proxy logs every single request. It can monitor latency. Do you want to know if an application is slow because of communication between this service and that service, or maybe blame this service, or maybe it's the other line of communication, or maybe it's the database? If you measure all those little segments and how long everything took, you can actually very easily find out at least who to blame for the slowdown. You can do things like routing. For example, I'm talking to service A, but actually the person who wrote the proxy knows that service A is about to be deprecated. You should be talking to service B. It will route the request for you. And that also allows for A/B testing. Is service A better than service B or not? Let's try out. You can do things like protocol translation. So for example, you upgraded the version and someone didn't upgrade yet. What do? Does it break? The proxy can actually do a translation from version 1 of the protocol to version 2. A really cool story by Lyft, who really kind of pioneered the whole idea of service meshes. I was in a presentation that they had at QCon, I want to say 2017 in New York, I hope I remember correctly. And they showed how they migrated from HTTP to gRPC as their main protocol of communicating between microservices. And obviously there is always some people who complain, right? Not I think gRPC is the greatest thing since sliced bread. Not as great as Kafka, but very great in itself. But not everyone agrees with me. So do I actually sit and argue with them forever? Or do I just say, proof of the pudding is in the eating, and I'm totally going to force them to eat it. And I'm going to force them to eat it by putting in a proxy that will just translate the protocol, and they will be doing gRPC whether they want to or not. Maybe they'll talk to the proxy with HTTP, The rest of the way will be with gRPC. So this is really, really cool. The last idea is to use the proxy for SSL termination, which means that you can save some of CPU cycles and make things a bit more efficient. The thing to get is that a lot of the intelligence is not actually in the proxy. So if you look at this diagram, you can basically see that you have the service. It is talking to Envoy, which is a type of proxy. You can see the HTTP, gRPC, all those. But you can see that Envoy is getting all the intelligence from what is called the control plane. This is where things like the service discovery happen. This is the thing when you put in the rules and say, hey, all this traffic routing, all this A/B testing, all this protocol transaction, the rules are in the control plane. So a service mesh is really a combination of the smart proxies that can do a bunch of things and the control plane that adds a lot of the business logic in there. And you can see that this, when you have microservices that communicate with a service mesh, they are more decoupled, not 100%, but more decoupled than they were before. You still have the point-to-point lines of communication, but you have a lot of flexibility because now you have the proxies who can kind of interfere and help you get a bunch of flexibility in the way, even if the application itself isn't the most brilliantly architected in the world. You get tons of operational transparency because you basically have like a mini sysadmin assistant sitting on every port, and you did absolutely nothing for data awareness. Sorry, we can't fix anything. So you have Kafka, we have the service mesh. You can see how one helps communication in one way, another helps communication in another way. How do we choose between them? Well, I think from the way I framed it, it should be fairly clear that we really don't want to choose. We want the best of both worlds because they each bring benefits in their own way. So, and then the core of this is that you really have two different paradigms. The REST gave you a request response paradigm. Service mesh basically added a lot of operability to it without breaking things like the low latency benefits, but it didn't solve things like a lot of bespoke APIs that are a bit more fragile. On the other hand, Kafka says it's event-driven or event stream. It's a whole new paradigm. And at least if you started with REST, it's a whole new paradigm. It has tons of benefits. And it's sometimes not every problem you can actually solve with an event stream. Like you may want to because you want to have the data and you want to have the continuous processing and you want to store, you want to have this shared source of truth, but not every problem is really amenable to that. If you need the low latency, it's kind of hard to really get away from that. So we're trying to think, how do we combine them together? And the first place we started is that, a lot of people use request response where actually Kafka would be fine. And maybe that's a good place to get started with Kafka. It's just the way that Lyft moved from HTTP to gRPC. They basically didn't tell anyone and did it anyway. What if we magically just shove in Kafka and kind of, make sure the events go to Kafka whether you know it or not? So this is kind of the architecture. The service still thinks I'm talking REST, I'm talking to my proxy, but I don't know it. I think I'm talking to another service with REST. But really, you have a proxy, and it's directing events directly to Kafka. So the events end up in Kafka, whether you know it or not. But now there's a question of how do you get the events from Kafka? Because the service that's supposed to get the events has to know whether it's asking for them from somewhere or like what the hell is going on. So it's kind of, this is not something that you can just paper over. It's not like gRPC versus HTTP that are the same paradigm, but just different protocols. You can paper over it from the producer side, like the producer can think it's doing HTTP calls, but the consumer has to know. So you can use it to get around some organizational boundaries, like the one guy who absolutely refuses to use Kafka, you can kind of sneak it in on him, but you can do a lot more. So we have the Confluent REST proxy that basically does bits of that. It's like you talk to it with HTTP and then it moves stuff to Kafka. So this is a proxy that actually does exactly what we described, and you can definitely deploy it on localhost in kind of a service mesh pattern, even though it doesn't have the control plane. So it's not 100% a service mesh. And we keep adding more protocols because, hey, protocols are fun. Why not? We're adding MQTT. We may add gRPC in the future. It's really good fun. But we notice that it's not 100%. It doesn't solve all that much of a problem. Another thing we can do, which we really like, is actually add Kafka almost as part of the control plane. Like we're already logging events. We want the control plane to log events, to time events, to give you all the metrics. What if it would also send events to Kafka? Not instead of sending them to the other service, but just send it to Kafka, which means that now you have, because Kafka scales so well, it's a very nice way to have a central log of everything that happened in your system. And you can use it for data analysis. Who is talking to who? Is there a service that actually nobody talks to? And maybe you can just retire the entire system. Are people using the old version more than the new version? Are there more errors in this version of the app versus the other version of the app? So you can get a lot of data out of this analysis. But of course, this means that the communication is still being done somewhat point to point, which is not something that I'm 100% in love with. Another thing we can do, this is my favorite, is actually, if you have Kafka and you're going to communicate to Kafka, why not do it in a service mesh fashion? Meaning, when you produce events to Kafka, you actually think that you're producing them to a fake Kafka that is on your local machine, but a proxy forwards it to the real Kafka. Why do we need it? All those benefits. What if Kafka moves? You're getting service discovery. What if you need a new protocol? Kafka upgraded the version, and do you really need to upgrade your client? What if you need SSL termination? So you have all those things that you get from the proxy, and you still have the Kafka as a shared service bus and a shared source of truth about events. So this is super valuable and something I'm super excited about, but it sounds like a lot of work. I mean, most proxies talk HTTP, maybe gRPC. How would they proxy the Kafka protocol? And it turns out that proxying the Kafka protocol is not that hard. You just move bytes along, bytes are bytes. But your real benefits are when you understand the Kafka protocol, because you can say, hey, this type of event should go to this Kafka or maybe the other Kafka. Maybe we're doing green, blue deployment and we want to move from one Kafka to another. So you have a proxy that is smart about Kafka and understands the protocol is way cooler than just a proxy that gives you transparency and you get some service discovery, but not even that much really. Luckily, our friends from Lyft, which have been pretty much plugged, I don't have any Lyft shares, so I'm just plugging them for free for this entire talk, but they did something amazing. They said, let's create a Kafka protocol filter, which is basically part of the proxy that Lyft owns, which is Envoy, and something that understands the Kafka protocol so we can start building cool logic. And the guy said, hey, you know, event routing is obvious, and load balancing is obvious, and maybe languages kind of paper over some bugs in Kafka clients that are not that great is obvious, but what other things would people do? He immediately got like 44 people who said, yes, let's do it, because everyone agrees that this is awesome. And they also started getting feature requests, endless stream of feature requests. Let's do tracing. Let's do compression. You can save a lot of money by compressing Kafka messages, but a lot of people don't enable it. Why don't we do it in a proxy? The proxy will compress and send things along. You can calculate all kinds of metrics. You can do validation. We talked about the schema registry, but can we actually prevent events from getting in that are not basically the client will not have to know about the schema registry, or it will know something, but we can have the proxy prevent events that are not schema compatible, that are not using the schema registry, like, you know, random line noise, from getting into Kafka by looking at the messages themselves. Or maybe say, I don't want create topic requests that request more than 500 partitions, because I know that this is not something that my Kafka currently supports. Some Kafka support it, but maybe not mine. I don't have that many brokers. So why not have a proxy look at the requests and immediately reject them, not even send them to Kafka? Automatic topic naming. I do create topic with a name, but you have naming standards and my name is not good enough. Name conversions. You can do a lot of pretty cool things. And the list of, if you go to this GitHub issue, which you have the details here, it's on the Envoy, sorry, pointing to something that you cannot see. The 2852 issue on the Envoy GitHub. And you can just take a look and see all those different requests. It's just endless. You can do dynamic routing. You can do double producing. Why not just send to 2 Kafkas and have it even higher availability? This kind of monitoring, this kind of mirroring, rate limiting is a big deal. The same things that we said about errors. Don't send all the errors, just part of it. You can do more and more. So this is like the coolest thing. And Envoy and us and maybe other people will be working on it, and I can't wait for this to come out. But when we kind of sat down and discussed how to do this proxy for Kafka thing, we found out that proxying the Kafka protocol is a bit challenging due to the way that Kafka has advertises the broker locations. You always have to talk to specific brokers in order to produce to specific topics and specific partitions. So you kind of have to have those direct line of communication. And Kafka will tell you who to talk to, but it has to know if you're still talking to the proxy, so Kafka will have to tell you something about your own local proxy. It sounded doable, but it also sounded like we may have to hack some things about the protocol. If you look at the thread, there's a bunch of suggestions on how to do it, and nobody was really happy with any of them. So we're still debating, but something that you can do almost for free, instead of putting the proxy on the microservice, put the proxy next to Kafka. And now Kafka knows exactly where the proxy is, and you still have a lot of the benefits of the protocol transaction, of the metrics, of the logging, of the SSL termination. So you get tons of those things with very little headache. And this may be the easiest thing and the first things that we will get done. And this is exciting because Kafka by default doesn't log that many. It logs metrics, but it doesn't log them all for all the requests. And if you try to log for all the requests, it kind of starts getting maybe slow about it. If you have this log for every specific request, you can find performance spikes. A lot of your troubleshooting is so much easier. So we basically get a lot of the operational transparency that was the thing that was most missing on top of Kafka. And this is very, very attractive for us. So just to sum things up, we started out with our microservices using point-to-point communication. And then we found out that as the system evolves, you don't check architecture the time you wrote it. You check, architecture is good if it evolves well. And we found out that our point-to-point REST communication does not evolve very well. So we said, okay, what's next? And Service Mesh says, add this proxy, which will give you discovery, and it will give you operational ability. This will give you a lot of flexibility. We said, communicate via Kafka instead of directly, and it will give you the single source of truth about your data. It will give you compatibility story. It will give you this immutable storage. And obviously you want all of them, so you can have both. And we just went through 4 different ways in which you can have both. Some of them are already totally doable, and some of them are coming really soon to your favorite proxy. So if you're wondering what's next, this is all open source and you should totally get involved. If you want to play around with Kafka and schema registry, check out our Confluent platform demo. If you're like, I know Kafka and I want to explore more about using it with Envoy or Service Mesh, take a look at the Envoy issue and see if you want to join in. And then there's a lot of ways to learn more about Confluent and about our products and the Confluent operator, because if you have a Service Mesh, there's a good chance you're running on Kubernetes, and the Confluent operator will be a very nice way to get started. And last but not least, we have a Confluent community, which is kind of a marvel of nature because 4,000 people from all over the world are answering each other's questions all hours, night and day, and we only pay about 20 of them. So this is still, for me, it's mind-blowing. I have a Kafka question and someone random from somewhere is going to answer, but then I do kind of the same, so what do you know? You're all welcome to join, and it's going to be very exciting. So thank you for joining us.